So here's a problem with a graph of f versus t. And whenever I see a graph of f versus t, I think I'm going to find the area, and the area is going to be equal to the impulse. And so my shape here is a triangle, and I know a triangle is 1/2 base times height, so I can write that down. 1/2 the base, oh golly, they didn't tell me what the base was, they just said it was delta t. I'll leave that in there for now. And then the height of the triangle is 36. So I have a formula with a delta t in it, but they didn't tell me what it was. So I go back and I read the question. I realize that delta t is what I'm supposed to find. So if I can figure out by some other method what the impulse is, then I can use this equation to find out what delta t is. That's what they're asking. So the impulse must have something to do with this graph. The impulse momentum theorem says that besides being the area and under the force versus time graph, impulse is also equal to the change in momentum, which, as long as the mass isn't changing, is mass times the change in velocity, which of course is mass times v number 2 minus v number 1. Well, let's see, what have we got here? V number 2 is out here. That's the final velocity. And it looks like that one's equal to 3. The initial velocity at t equals 0 is down here. That looks like v number 1 is equal to minus 3. So that tells me that this is equal to mass times v number 2, 3 meters per second, minus v number 1, minus 3 meters per second. So that's the mass times 6 meters per second. I think different people have different masses, so I'm not going to plug that in. But the impulse momentum theorem then says that this thing here has to be equal to this thing there. So I set those equal to each other. The mass, whatever it is, times 6 meters per second, that has to be equal to 1/2 the delta t, that's what I'm looking for, times 36 newtons, and I can solve for delta t.